This is MxT, Mamba Cross-Transformer for Image Inpainting. Deep learning-based image inpainting fills in missing regions of an image using deep neural networks to generate visually coherent content from surrounding visible information. Recently, state space models, also called Mamba, have demonstrated promising advantages of long sequence modeling and linear time complexity in natural language processing. We observe that Mamba and Transformer exhibit complementary strengths. Mamba is good at learning long-range pixel-wise dependency, which is computationally expensive for the Transformer. Conversely, Transformer is good at encapturing global interactions between localized patches. Such spatial awareness is an area where Mamba lacks, due to it is designed for sequence modeling. The proposed MxT is built upon a U-net shape architecture with 7 stages. Each stage has several proposed hybrid blocks. Each hybrid block combines a Mamba block, a spatial reduced self-attention, and a context broadcasting feed-forward network. The proposed spatial reduced self-attention module, designed to leverage the capability of Transformer for capturing global correlation while enriching local context detail. For the self-attention, the spatial dimension is reduced to 8 to reduce the computational complexity. We propose leveraging Mamba block to modeling the flattened feature, thereby capturing long-range dependency at the pixel level, which is expensive to capture by self-attention. To adapt Mamba more aptly for vision task and enhance its ability to maintain positional awareness, we incorporate positional embedding into the module. We propose context broadcasting feed-forward network, which integrates a global processing stage after post-GDFN to facilitate the learning of dense interactions within the self-attention layers, thereby enhancing the effectiveness of the hybrid module. As shown in the figures, MxT maintains consistency from the visible regions to the missing regions, such as effectively reconstructing elements like a missing hat. Additionally, MxT renders features like eyes with improved fine-grained details, showcasing its strong capability in learning complex representations. More impressively, MxT is able to handle the very high-resolution image inpainting.